Mode 1 operation. Sorry, mode 0. Timer 0, mode 0. How you are going to decide it is a timer 0 and mode 0? T mode register filled with a LSB bits so that it will be going to take it as a mode 0. If M1, M0 and M1 will be 0, 0. When C bar T bar is equal to 0, so that we will have a timer 1 with respect to the mode 0. Mode 0 especially we have a 13-bit counter here. TH0, this timer will be loaded with a TH0 will be 13 bits and TL0 will be 5 bits. Okay, rest of the bits we are not going to add here. Okay, so that this is a basic diagram. We are not going to study programming with respect to the mode 0. We are going to study programs based on mode 1, mode 2 especially. Here oscillator with respect to the it will be divided by 12 clock cycles, that is 6 machine cycles or clock cycles we are going to divide. If C bar T bar is equal to 0, then only it will be going to connect with respect to this. If it is C bar T bar is equal to 1, it will be connected to pin, counter pin it will be going to connect. That is the meaning. If C bar T bar, here C colon T bar is there now, based on that it will be going to select the switch. If it will be going to connect with respect to the timer, then the timer will be run. If it is going to connect with respect to the counter, counter will be going to run outside the microcontroller. If it will be connected with respect to timer, the switch will be closed condition. The control unit with respect to the AND operation TR0 we are going to apply. TR0 means we are going to give some timer pulse we are going to apply with respect to this. Means it is like positive clock pulse we are going to apply. Here we have a gate signal with respect to ones and zeros. With respect to the NOT gate we are going to use whatever the data we are going to give, that will be inverted with respect to that we are going to get. This will be interrupt pin. Interrupt pin we are going to connect with respect to the OR gate, and it will be going to OR operation with respect to the two different input for the AND gate. Okay, then with respect to the high output, it will be going to connect the control switch. If it is getting 0 output, we are going to open the circuit. If it is open, it will not be work. If it is closed, then only it will be work. This will be control will be working like a switch. Control unit working like a switch. So that once it reaches maximum, then again it will be going to set with a TF0. TF0, then it will be going to give it to the interrupt terminal. This is the basic working of your mode 0, timer 0, mode 0 for 13-bit counter. Okay, make a note of this. Then we'll discuss about TCON register, timer control register. Or
yes, sir.
next coming to the Okay, here how we are going to timers of 8051 do starting with start and the stop by make use of hardware and software control. How we are going to use. Here we are going to use the timers is started by instructing the set timer start bits TR0 and TR1. Okay, see here in using software we are going to start and stop the timers means TR instruction. Here they had given some TR. How we are going to start and stop by make use of software as well as hardware. We are going to start that pin, that is TR0 or TR1. Okay, how exactly we are going to start with respect to using hardware and how we are going to using software. Software means we are going to use some of the instructions to start over the TR0 and TR1. Or else if you are going to use with respect to the hardware, external circuit we are going to connect with respect to this, we need to apply external clock pulse. Based on that, it will be going to start the signal. Okay, if I'm going to using software to start or stop the timer where gate is equal to 0. Gate is equal to 0. Initially, gate will be make it as a 0. The start and stop of the timers are controlled by the way of software by making the TR bits as a high means the set bit instruction starts it, it will be going to stop by the clear instruction. If I'm going to use set bit TR0, set bit means we are going to make it as a TR0 as a 1. So that TR1 will be take it as a on position. If I'm going to use an instruction set bit TR1, if TR1 is equal to 1 set bit, if I'm going to set the bit at TR1, it will be going to start. Okay, set means we are going to load logic 1 to the TR0 or it may be TR1. If I am going to stop this action, I am going to give it as an instruction that is clear 0 or clear TR0 or clear TR1. If I am going to give clear TR0, it means that TR0 will be make it as a 0. It means it is in the off condition. Then if I'm going to use CLR TR1 instruction, it will be going to make a TR1 is equal to 0 so that it will be in the off position. Okay, when these instructions start and stop the timers as long as gate is equal to 0 in the TMOD register. These instructions will be working with respect to the start and stop with respect to gate is equal to 0. When we are going to give it as a gate is equal to 0, which gate? Here we have a gate terminal in the TMOD register. That gate is equal to 0. When gate is equal to 1, we are going to use for the some other purpose. That is the meaning. Okay, here with respect to that we are going to use. Then hardware way of starting and stopping the timer by external source is achieved by the making of gate is equal to 1. That is TMOD register. If gate is equal to 1, we are going to use it as a hardware. Means we are going to connect external circuit or we can give a clock pulse to the that if I'm going to apply a clock pulse, TR0 or TR1 will be going to set. If I'm going to reset the TR0 or TR1, the TR0 and TR1 will be in the off condition. It is like a switch. Like that, we are going to operate your TR0 and TR1. TR is very important to run the program in all modes, mode 0, mode 1, mode 2, mode 3. Here also we need to give a TR signal. TR signal with respect to TR set bit TR means we are going to give 1, then only it will be generating a 1. Whatever the output we are going to get, based on that we are going to get a output here. Then by make use of this, it will be going to start conducting like that. Okay, make a note of this. If I'm going to give it as a gate here, see, consider this TMOD is equal to 0001 and 0010. What happens? It is which mode and which timer? C bar T bar is equal to 0 means timer will be working. It is in timer 0 mode. Timer 0 and 000110 mode 2 operation it will be going to take. If I'm going to give gate is equal to 0, it will be a software means we need to give an instruction for the TR. That is the meaning. By make use of these bits, we are going to identify whether it is a software or hardware external circuit we need to give. See, timer 0 mode 2 operation it will be going to take. C bar counter or timer is equal to 0. It will be going to use as a external clock source. When gate is equal to 0, we are going to use an internal means software to start and stop the method. Got everyone? Any doubts?
No, sir.
Please make a note of this. Then we'll go for T-con register. Or
Yes, sir.
move to next one, that is T-con. Timer control register is an 8-bit register. Here we have a bits interrupt 0, interrupt enable 0, interrupt 1, interrupt enable 1, and TR0, TF0, TR1, TF1. Timer 1 overflow flag, timer 0 overflow flag, TF1, TF0, timer 1 run control bit, timer 0 run control bit. Here we had given these are the 8 T-con register, that is timer or counter control registers. How we are going to use, we can discuss later. Make a note of this T-con register. These are the bits 0 from LSB to MSB. This is a bit 0, IT 0, interrupt 0, interrupt enable 0, and interrupt 1 and interrupt enable 1. These lower 4 bits are set for the controlling the interrupt bits, and these higher 4 bits we are going to use it for the store the TF and TR bits of both timer 0 and timer 1. TF and TR means time overflow flag and time run control bit. Here the timers are started by using the construction of a set timer start bits TR0 and TR1. Based on that, it will be going to run the T-con registers. That is why we are going to call it as a timer control register bits. They can be cleared by clearing these bits. So the timer counter is, it is in the maximum value. It will be going to set for the flag TF0 or it is TF1. Timer flag will be the maximum value. It will be going to set for the TF0 and TF1 timer flags. At that point, it will be necessary to know the TF and TR for the timer 0 and timer 1. The T mode will be controls the timer modes. Another register called the T-con register. Timer control registers we are going to use. In this, we have a lower bits of T-con register can be interrupt functions. Next, we are going to use mode 1 programming. How exactly we are going to do the programming in mode 1? Okay, these are the mode 1 programming. First, you can take the characteristics and operations of mode 1. These are the characteristics and operations of mode 1. How exactly we are going to deal with mode 1? It's a summary. It is a 16-bit timer. Okay, so that it will be allow the value of 0000 to FFFF. It will be allowing from 0000 to FFFF. It will be loaded into the timer registers, both TL as well as TH. Why? Because it is a 16-bit timer, but microcontroller is having 16-bit data wise, so that we are going to divide that into higher byte and lower byte. Timer higher byte, timer lower byte, that is TH and TL. Okay, we are going to add it lower 8 bit and higher 8 bit. Okay, after we are going to load with respect to the TH and TL, what it will be going to, how it will be going to start with respect to the 16-bit initial value. The timer must be started. We need to start the timer, and we are going to done with the instruction set bit TR0 of a timer 0 and set bit TR1 for the timer 1. For example, if I am going to use the timer 0, we need to set for the timer 1. If I am going to set for the timer 0, we need to set for the timer 0. Okay, for example, if I am going to get the signal from TR0, so that the instruction set bit TR0 we need to give for timer 0. If it is timer 1, what we need to do? Set bit TR1 for timer 1 we need to give the instruction. These instructions is differ for timer 0 and timer 1. This is for timer 1 and this is for timer 0. Okay, after the timer is started and it will be starts to the counts. It will be going to start the counts. With respect to that, it will be going to count until it reaches the limit of maximum FFF. It will be going to reach. When it will be rolls over from FF to 00, it will be going to set for the flag bit. That is your TF timer flag will be going to set. Okay, the meaning is the count is starts from 00002 FFFF. Once we are going to start the counter, it will be starts counting from 0002 FFF. Once it reaches FF, automatically it will be again it will be coming back to 00. Once it reaches to FF and again come back to 0, at that time it will be going to set with a timer flag. That is TF flag will be going to set. Okay, each timer has its own timer flag, that is TF0 for timer 0 and TF1 for the timer 1. Okay, this timer flag can be monitored step by step. It will be going to monitor. It will be like loop. Okay, once it reaches maximum, again it will be going to give the carry signal, carry flag. It will be going to generate. Again it will be reaches to 0. Once it reaches to maximum FF, after we are going to increment, it will be going to 00, carry will be generated. Like that it will be going to work. Then when this timer flag is raised, one option would be the stop the timer with the instruction clear TR0 and clear TR1 for timer 0 and timer 1 respectively. Okay, once it reaches 00 means maximum after FF, it will be going to generate a carry. It will be going to stop the operation by make use of the instruction clear TR0. Now clear TR0 will be got clear, so that the operation will be stopped at that time. Okay, next we'll discuss the block diagram. Make a note of this. Make a note of this. We move to next slide.
Yes, sir.
Okay. This is the basic block diagram for your mode 1 programming. Mode 1 programming. We don't know whether it is timer 0 or timer 1. Either it may be timer 0 or it may be timer 1. That will be based on the input bits we are going to give. Okay, here the first block is external oscillator frequency, that is 11.0592 divided by 12. We are going to get some frequency that this signal is considered with respect to that. C bar T is equal to 0, so that it will be act as a timer. This is TR0. Here we have a special category of this block diagram is TR and TF. When it will be going to act TF and TR. Okay, initially, what is the procedure? What we discussed in the last slide, the same. It is 16-bit timer. Okay, here we have a timer. This will be a 16-bit timer. Therefore, it allows value from 00 to FF. Okay, when we are going to load with a 000 to FFF, maximum it will be started with a 00, end with a FFF to be loaded. Why? Because it is a combination of TL as well as a TH. Okay. After we are going to load TH as well as TL loaded with a 16-bit initial value, the timer must be started. Here we have a TR. Timer is here we have a timer. This will be set with respect to TR0. If I am going to take an instruction set bit TR0 means I am going to set the bit across this. TR0 means it's a timer 0. If I am going to set this, whenever we are going to get the positive here with respect to that 1 into 1 we are going to take 1, it will be increased with a 1 pulse, and next pulse it will be 0, it will be going to take delay. Another next positive pulse, it will be multiplied with a 1, again it will be going to count with the next pulse, that is 002. Again it will be going to take some delay, again it will be keep on running from 000 to FFF. It will be going to vary from 00 to FF. Each and every bit it will be going to take 1 bit delay. Why? Because here we have a clock cycle of having both positive as well as a negative signal. Based on that, it will be going to increase. Once it reaches FF, if I am going to add FF to 1, what you are going to get? 000 followed by 4 zeros followed by 1 we are going to get. That 1 will be stored across your TF. 1 will be stored with respect to TF, so that it will be the TR will be stop. How it will be going to stop? We are going to give an instruction, that last instruction what we discussed in the last slide. This instruction based on clear TR0 or clear TR1 we need to give, so that it will be stop the operation. If you want to continue this, again we need to start with a set bit TR0 or set bit TR1. Again it will be start from 00 to FF. Like that we can repeat. Any doubts? Any doubts with respect to this block diagram programming for mode 1?
No, sir.
Okay, here I have given the steps. Okay, how exactly we are going to use. First make a note of this, then you can make a note of that slide. After finishing this slide, please inform me. I will move to next slide. Over?
Yes, sir.
Note of these steps. Then we'll discuss the programs based on the mode 1 program. First step will be load the tmod value register with respect to timer 0 or timer 1. Load the registers with TL and TH. Keep monitoring the timer flag TF. Once whatever the number, if you are going to load TH and TL, it reaches maximum, it will be going to generate a carry signal. When it gives carry signal, the carry flag will be set, that is TF flag will be set. When it will be going to set, this is the instruction we are going to jump if no bit, TF, jump if no bit. Okay, based on this instruction, we are going to observe this flag set. Once it reaches, once we are going to give a carry flag is equal to 1, it will be going out of the loop. When TF becomes high, TF is equal to high, it will be go out from the loop, so that timer will be stopped. Then after clearing TF flag, once it reaches 1, carry flag will be 1. After clearing this, then only we can go back to step 2. Again it will be keep on continuing. Again we can load the new number or same number if you want, you can load and we can program once again. That is the procedure. Have you received assignment number 4? Please respond. Have you received assignment number 4?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
When is the last date to submit?
24th June, sir.
9 days I had given. 9 days or 8 days? From yesterday it will be 9 days, I think. Please submit in time your assignments and quiz. It carries good marks. Over?
Yes, sir.
Okay, thank you. We'll continue in the next class. The programming will be continued by next class.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Sir, can you send module 3 notes PPT, sir?
Module 3.
Yes, sir.
Okay.
Thank you,
We'll
sir.
share it in the Teams. You can take there. Okay.
Okay, sir. Thank you, sir.
Okay.